Okay, so in the last class, we have discussed about the linked list in Java. Now we got to know the exact difference between the array list and the linked list, and you know now we have seen some methods which are very specific for linked list, and we have understood about the exact differences. Okay, here you have dynamic array. Here the linked list uses doubly linked list data structure. And there are so many things that are involved inside in array list topic as well as in the linked list topic, right? And today the classes is going to be on the vector on the stack. We look at the hierarchy of the collections. So by now we know that collection is an interface, right? And the list is an interface, and these are the classes. ArrayList is implementing the list interface. So we have completed discussing about this ArrayList as well as the linked list. So we are clear with these two, right? ArrayList and the linked list. Today we will understand. Today we will cover these two things. Okay, what is vector and what is stack? First of all, let us understand what is a vector. So by looking at this, we can come to one conclusion. What is that? A vector. So basically, these are the classes. Okay, ArrayList, vector, linked list, and stack. These are the classes. Vector is a class that implements the list interface. So one point is very clear. Right? Second point that I can say is I can have one conclusion, right? That conclusion is this array list and this vector, the internal data structure is same. When I say internal data structure, so for the array list, the internal data structure is internally it is using a dynamic array. Even the vector is also using the dynamic array. Okay? So there is only one difference between these two classes. What is that is ArrayList is non-synchronized. ArrayList is non-synchronized in nature. Non-synchronized. Okay. So multiple threads can have access at the same time with the ArrayList class. So vector is what? Vector is the synchronized. This is the only difference. Vectorized means at any point of time only one thread can access to the vector class. So it will not permit the multiple threads to get access at the same time. So when it comes to vector, ArrayList is completely non-synchronized. So multiple threads can access at the same time. So when I say non-synchronized, it also means that the performance will always be high. Performance is always high. Okay, when I say synchronized, it also means that the performance is low. Performance is low. Right? When I say non-synchronized, it also means that it is non-thread safe. Non-thread safe. When I say synchronized, it is thread safe. So in the multi-threading concept, you will understand this. What is a thread safe? What is non-thread safe? What is a synchronization? What is a non-synchronization? Right? So when you hear a word like non-synchronized, so the follow-up things will come into the picture. These are the follow-up things, performance thing as well as the thread safe things. Right? So this is applied for vector. These features are applied for vector. These features are applied for ArrayList. Apart from this differentiation, everything remains same. Let us see one example. ArrayList, right? ArrayList we know, so we will see what is vector. Vector. Let me say something like for integer. Say I want to store some integer. List of integers. Equal to new vector. Okay. So you can add what? You can add entries. So list dot add. I want to add some numbers. Let me add 10. 10, 20, 90, 100. Dot outer println. Okay. If you see, can I say that the insertion order is preserved? Yes or no? Is it?
Yes.
It is same like ArrayList, right? Can I say that duplicates are allowed by looking at the output? I have added a duplicate here. I have reduced one duplicate here. Duplicates are allowed. Right? So all the features that are already there in the array list, the same features, okay, the same features are also applied for the vector as well. The difference, there is a difference only with the synchronization concept. Apart from that, everything is going to same. Even the array list allows null values. Here also you would see what null values are allowed. Everything is going to remain same. But here one thing is about the capacity. Now, someone tell me, when I try to call the size method on the variable, what would be the answer now? If I call size method, 5, because size is proportional to what number of values that you are adding, right? You have 5 values, right? So obviously the size becomes 5. But when you see the capacity here, list dot capacity, the moment you start this, okay, the moment, let us forget about this. The moment you start creating an object for the vector, okay, the moment you start creating an object of the vector, by default the capacity, what is the capacity for ArrayList by default? 10, right? So the same capacity is also applied for vector also. 10. So now you got to know the difference between size as the capacity. Size is the actual values that you are adding. Capacity is the size of that particular array. The size that gets created the moment you start creating that object. In this case, you are creating the vector object, right? By default, the capacity for the vector class is same as the capacity of the array. Are you getting? Now see the the capacity, right? Now let us understand how this capacity is getting manipulated. Let me add 5 more numbers. Okay. Now can someone tell me what would be the size? Okay, I am commenting this. Okay, I am also commenting this. Now what would be the size now? 10, right? Size is 10. Okay. Now let us try to see the capacity here. What should be the capacity? 10 only, because the default capacity for vector is 10. Same like the ArrayList. The moment I start adding the 11th element, okay, I am adding the 11th element. However, the default capacity is 10. Focus here. Default capacity is 10, right? I am trying to add the 11th element. Right? What internally will happen, right? Array will be usually internally the data structure is dynamic array. The size will be increased dynamically. To what extent? That is the question. The size will be increased dynamically. The size is growable nature. To what extent? Right? You have added the till here. Okay, you are able to see that the size is 10 and the capacity is 10. The moment you start adding the 11th element, dot add. Let me add something like 18. Okay. Can someone tell me what would be the size now? I have added the 11th element. What would be the size? 11 values, right? So totally there are 11 values. 11 is the size, right? Okay. But the default capacity was found to be 10. Default capacity, the moment you start creating the vector, the default capacity is 10. Okay. After adding the 11th element, now check the default capacity. Now check the manipulation that has happened in the capacity. Check the size of the vector now. The moment you do list.capacity, now you would see that capacity is 20 now. I can say that formula is like default the capacity grows, which is equal to default capacity into 2. The moment you fill all the existing capacity, okay, the moment you start adding the 11th value, right, the size will be doubled in the vector. Are you getting? This is the proof. So just try to print the capacity just before adding the 11th element. So till the 10th element, if you see the capacity, till the 10th element, the capacity remains 10 only. Capacity remains 10 only till the 10th element. The moment you start adding the 11th element, the size becomes 11, the capacity becomes 20. The formula is what? Default capacity into 2. Are you getting what I'm trying to say? Hello?
Yes, sir.
Yes, sir.
So 10 values by default 10. Okay, the moment you start at the 11th element, the default capacity will become 20. Okay, after filling 20 elements, the moment you add 21st element, what would be the default capacity? Can someone tell me?
40.
40. That's double, because now the capacity is 20, no, 20 into 2. After adding the 41st element, what would be the capacity? 80, right?
80.
Right. So it keeps doubling. Are you getting? So you can see an advantage. Okay, if you know that you want to add some set of values, if you know that those values are scalable in nature, in the future those values will be increased. Okay, if you know your requirements in advance, instead of creating an array with the size of 1000, okay, you create I mean, instead of creating a vector with the size of 1000, you create a simple vector like 500. Okay. After fulfilling this 500, after achieving your first target, then the data structure will take care to increase the size of the vector. Will be double. Are you getting? Okay. Apart from this, everything will be same except for what? Except for what? The synchronization or non-synchronization, performance, and thread safety. Hello, getting now? Can we jump into the next one? Yes, no?
Yes, sir.
Okay.
Yes, sir.
Now you see, now we have something to discuss, which is what? Stack. So the stack is something very interesting, guys. Okay. When I say stack, integer s equal to new stack. Have you seen this? Anyone? Did you do any research today about vector and stack?
Yes, sir.
Then what is the internal data structure of stack? Anyone tell me?
First in,
Last
first
it follows last in first.
LIFO. Correct. LIFO. What does it really mean? Okay, let us quickly add 3 elements. Okay, I want to add something like I want to add. Okay, let me add 100. Let me add 200. Let me add 300. Just see what is happening the moment you start printing the reference variable. Okay, you see 100, 200, 300. You don't see any differences in the insertion order. It is getting printed exactly the way you have added. The insertion order is completely preserved. But behind the scenes, what you would see is it is following a kind of data structure. That data structure is called LIFO data structure. Okay. Interview room, you might be getting a question. Can someone tell me what is the data structure for ArrayList? Dynamic array. Internally, it uses dynamic array. What is the data structure for linked list? Internally,
W linked list.
W linked list. What is the data structure for vector? Dynamic array. I said both are similar.
Dynamic array.
What is the data structure for stack? LIFO.
LIFO.
Okay, now see the addition operation. I mean, the moment you start, pushing the elements, or the moment you start adding the elements, okay, the elements will be added like this. Just imagine that you have a table, right? Imagine that you have a table. Okay, when we are in the school days, right? We submit records, we submit books, right? Like the same analogy can be applied here. Okay, 100 is getting added now. 100 will be settled at the bottom. Then you are adding what? You are adding the something like 200, right? 200 will be settled on top of 100. Okay. Then you are adding what? Then you are adding the 300. 300 will be settled on top of 200. Okay. So internally, the two-string method is designed in such a way that the moment you start printing the reference variable, this is how it is going to extract. Okay. The two-string method extraction is completely different. Two-string method will extract from bottom to top. It doesn't mean that it is going against LIFO principle. Data structure is, okay, the element that is getting added last can be retrieved first. But sir, but when we try to print the same thing in the console, it is not like that. It is something different. Don't go by this. Okay, don't go by this, because internally it is taking it's calling a two-string method. The two-string method of stack is designed in such a way that it is following insertion order. But what is actually happening inside is there are some methods. There are some specific methods for the stack class. Okay? Take the reference variable.
Pop.
Yeah, correct. Correct. Take the reference variable, and there is a specialized method called peak method. What the peak method is, when you just click on this, you would see something like 300. Okay, but the way you have added is 100, 200, 300, but you are seeing the last element. Why the last element is getting displayed on the console the moment you start using the peak method? Very simple. Go back here. Okay, it is just like seeing this record, seeing these values from the top. For example, if there is a stack of books, right? There are some stack of books. Okay, when you just look at the stack of book from the top, you would see the first book, right? You would get to know only the first book, name of the first book. So peak method is also doing the same thing. Peak method will only see the value that is on the top. The last value, which is always on the top, that will be retrieved by the peak method. That's why the moment you use peak method, it is retrieving the last element that has just been added, which is 300. Right? Are you getting? Yes or no? These are the internal things. Okay, we are not, we don't use this stack, we don't use this vector anywhere unless and until there is a demand for synchronization. Okay, these are data structures that are used very lessly in the projects. You go with ArrayList or linked list, but for the interview purpose we are learning this. Right, so this is the importance of peak method. Okay, and there is another method, specific method. These methods are very, very specific for a stack. The push method is there. This push method will accept an element. Okay, any element, it can be the number of integers. It is just like the add method. Push method is just like the add method, but this push method is very specific to stack. Very specific to what? Very specific to stack. So what you just did, you have just pushed 100. So you have just pushed 100, right? So this 100 will be pushed on top of the, right? After pushing the latest element, when you just try to use the peak method after pushing the latest. So let us use the push method here. Push method after this. After using this push method, you just want to peak. Okay, now what would be the answer, do you think? So I am using peak method for 2 times.
300, 100.
Exactly, 300 and 100. Because until here, the last element is 300. After adding the latest value, this becomes the last element. That's why 300. Okay. There is a method called pop method. Pop method will not accept any argument. See, you are not passing any argument. You just say pop. Reference variable dot pop. After using this pop method, right? When you see when you want to see the values that are there in the stack class, okay, the last value will be removed. Okay. So what happened? 100 is added, 200 is added, 300 is added, right? So this is after this, I use pop for 2 times.
Correct one.
Okay, no. You will understand it. Correct one. Okay. So this is printing all the elements according to the insertion order 100, 200, 300. Okay. After this, you are using the peak method. What peak method is doing? Peak method is just fetching the top element, which is what 300. Okay? After that, you are pushing 100. After pushing 100, you are using peak method, it is 100. After that, you are using what? You are using the pop method. Okay? So this pop method is removing what element? The latest element, okay, the topmost element. 100 will be removed once again. Pop operation, 100 will be removed. Okay? After removing this, you are just printing the reference variable, and these three things will be displayed on the console. 100, 200. Getting this? Push is removing. Push is adding, pop is removing, peak is just seeing the topmost value in the LIFO data structure. Are you getting? Yes, no?
Yes, sir.
This is just, just learn what is what, that's it. And it is using LIFO, but there are some reasons why it is using LIFO data structure. So for now, since we are not going into depth, no one is going to ask you how the LIFO data structure has been implemented internally. Those questions cannot be expected. If you say, okay, it uses LIFO, that is more than enough. And if you also say it has three methods, one of the methods are, like push method, pop method, peak method, more than enough. And you know what is an empty method? Empty method is what? Empty method to check if the stack is empty or not. So we know this already. And search method, you want to find a particular element based upon the, you will just pass an object by using the search method. If the object is there, it finds the position. Right? So these are the specific methods for stack, and these are the specific methods for, vector. I mean, not specific method, these are commonly used, but this capacity method cannot be used in the array list. Remember, there is no method like capacity to be used in the array list. This is not there in the array list. Only you can use this capacity in the vector because it's a legacy method. So they thought that they do not want this in the for the array list, because these are just to know the internal things. They thought it is not required, so that's why they did not use this method in the array list concept. For the vector, it does. Right? Let us design a small application based upon these collections. What and all we have discussed so far, we will understand one by one. Okay? Let us design a student application. Let me remove this. So I'm going to add one more class here. Raise new class, public class name. Can someone tell me some three properties about a student? Any three properties?
Name, roll number,
Name,
school.
okay. Roll number.
Branch.
Last one, what is it?
Branch.
Branch. Okay. So name usually will be of what type? String type. Roll number usually of what type? Integer type. Branch usually of the string type. Right? So we have three attributes here. Three attributes. Okay. It's a good practice to take the attributes as private, because encapsulation, we have discussed about this. Right. To assign values, because these are the instance variables, right? To assign values to these instance variables, what we require? What we require?
Get method, set method,
Setters.
Apart from that,
constructors,
Constructors.
constructors. Okay, we can choose all our constructor. Okay, source, generate constructor using fields or our constructor. Whenever there is, remove the super keyword, not required. By default, compiler will be placing it. Okay. Whenever you take the all argument constructor, it is always good to keep a no or constructor. Highly recommended. Okay. Apart from this, how to get the values from the no, from the object. Get means what? Getters, no? Forgot, huh? Getters. You have getters, no?
Get.
Remember, no? Getters. We can generate both getters and setters together. I am checking everything here and generate. Okay. You have only one option to get the values, but to set the values, you have how many options? Two options. You can set it through constructors, or else you can set it through setters. Okay. So our student class is completely clear. So for the simplicity, we will also override the toString method. Right now, my job is I want to do what I want to take three or I want to take 5 students. I want to create 5 student objects. I want to store those 5 students in the array list. Right now, you tell me what would be the generic type here. When I say array list, I must be passing some generic type here. No, it should be integer or string or what should be here. My intention is I want to store student objects. What should be
Student.
correct? It should be student object because my intention is to pass the student object. Yes or no? Array list students equal to new array list. Right? So my array list is designed to accept what objects? Student objects. But did I create any student objects? No, right? My intention is what? My intention is to add 5 student objects to this array list reference variable. How to create student object?
Student obj equal to
Yeah.
student.
Student s1 equal any variable, new student. For the simplicity, I am taking the all or constructor. So all or constructor, the name can be like Raju. Roll number is 101. What branch we can take?
Yes.
CS branch. Okay. So like that, we will take 5 students. Okay, S2, S3, S4, S5. Second name Raju, Mohan. Okay, third name, Suresh. Fourth name Ramesh. Fifth name Vignesh. Okay, 101, 102, 103, 104, 105. TS, what are the other branches? Can someone tell me?
ECE, mechanical.
ECE,
Mechanical.
EEE. Let me take another CS. Okay. We will take. There is a reason I'm taking I'm taking the same branches. Okay. There is some reason. I have 2 students of EEE department. I have 2 students of CS department. Okay, after doing this, what will happen if I just print this? What will happen? Hello.
Nothing will print.
Yeah, good. Empty list. Nothing is there. No, we did not add anything, right? List is empty. Right? I have 5 student objects. I want to add each and every object to this list, which is what? Which is student's reference variable, right? What I can do, I can use this reference variable student. My reference variable will accept only student objects. How I can confirm that the generic type is student, right? So I can do what? Students dot add. I can pass reference variable directly. Do you agree?
Yes.
Or else I can do like this: students dot add. If I don't like to pass reference variable, I can pass this also directly. Do you agree?
Yes, sir.
Both are same. Here I am dealing with reference variable. There is an address. Here no address, but I have the value directly. Even if I use address here, this address is again having this value. Are you getting what I am trying to say? In some places you will be seeing the direct objects. Someone is asking any question. Pavani?
No, sir.
Yeah. So now let us add this because we have created reference variable, that s1 s2 students dot add, okay, s3 students dot add, s4 students dot add, s5. Now if I print students, what would be the output? Now do you see some values? Yes,
Values will
some
print.
values will
Yes,
be
sir.
there.
That data will be printed.
Every student and the values are preserved. Insertion order is preserved. Do you agree with me? Everything is. It is
Yes.
just like ArrayList is preserving insertion order. So this is what it is, right? And if I say something like student s6 equal to null, if I add students dot add s6. Don't you see null also? It is applicable for all syntax, integer, string, or student object, whatever it is. Right? Now I have added the elements. Okay. Now my intention is I want to run a for loop. I want to run a for loop. I just want to print what I want to print. Okay. Only the triple students names. The question is understood now. I want to run a for loop or enhanced for loop, whatever it is. So what is the how I can write an enhanced for loop? How I can build an enhanced for loop? Can someone tell me?
For.
We can use for keyword, no? For.
Yes, sir.
And let us create the opening closing brackets. Keep a colon in between. On the left hand side, what should be the data type here? Can I say student? Student. What can be variable? Any name you can take.
XX.
What should be the value here on the right hand side? This reference variable. Yes or no? Reference variable.
Yes,
The actual reference variable. Dummy or temporary reference variable. Data type. Can I say that this enhancer for loop is built in such a way that it's going to iterate for 5 number of times because the size of the array list is 5. So no, it's going to run for 5 number of times.
Yes, sir.
Right? Very simple. How? What is the proof that it is going to run for 5 number of times? Okay. So let us try to execute this. How many times you see A? 5 times, no? It's a proof, right? So this is not a meaningful logic, but can I confirm that it is running for 5 number of times, which is equivalent to the size of the array? Yes or no?
Yes, sir.
Right? Now see,
Yes, sir.
my intention is if okay, I'm placing condition. What condition? Students, okay, not student, x dot equals, okay, not x dot equals, x dot get name. So first on the first iteration, the object is s1, right? In the s1 object, I want to get the name of the student, or else I want to get the department of the student. Get branch we have taken. Get branch. Okay, dot equals. Okay. Triple. What this condition says, every time the for loop enhanced for loop iterates, okay, on the temporary variable. First time the temporary variable is going to hold the s1 reference variable, right? Second time s2, third time s3, fourth time s4, fifth time s5, right? I'm catching this temporary variable which is x. On the s1, I'm extracting what? I'm extracting branch. Can I extract branch on s1? Because s1 is the combination of name, what is it? The roll number and department, right? I just want to branch. Okay, I just want to extract the branch. So it is going to return me the exact branch of what? Exact branch of Raju, which is CS. Okay. I am comparing the CS with triple E. Not matching, right? Not matching means this if condition will never get executed. But if it is matching, what I want to do, I want to print that name of the student. If I run this piece of code, don't you think that only the triple E students will be displayed on the console? Suresh, Vignesh. Hello?
Yes, sir.
I'm trying to understand the complexity here.
Yes, sir.
We are not only dealing with the S1 reference variable, we are also internally dealing with each and every data that this S1 reference variable is holding. So this is a kind of, even in it is a kind of advantage that we have. Okay, we can. This is an advantage of for loop. You run that with the help of you by using getters, or like you can also use setters. If you want, you can get the data of a particular, by following a particular pattern. Triple. I want to get the list of students who are not in the triple E department. I want to get the list of students who are not in the triple E department. Can I just add the not here? Hello? If I just add the
Yes,
not
sir.
symbol here, now the result is completely a complement result. Complementary result, right? People who are not part of triple E department, Raju, Mohan, and Ramesh. Able to see? Hello? Yes, no?
Yes, sir.
Now I want to extract the people, I want to extract the student who are studying in ESC department, CS department, as well as what? EC department. How I can do that? Or CS department and triple E department.
And operate.
Yeah, can we use AND operator here? Can we get that? Can we get the names of the students who are? No. Sorry, you cannot use AND operator because if you use AND operator, it will never work out. Okay, I can use. I want to print either they should be CS students or they should be triple E students, because one student cannot hold 2 degrees, right? One student
Yes, sir.
cannot hold 2 degrees, right? That condition will never satisfy if you use AND operator. This is going to get satisfied. You will be seeing the student. They are CS. Their names will be printed. If they are triple E, their names will be printed. But it is not going to print the. Not going to print the EC student. Raju, Suresh, Ramesh, Vignesh. Are we getting the right answer? Raju, Suresh, Ramesh, Vignesh. Because Mohan is part of EC, right? Hello? Getting?
Yes, sir.
Yes, sir.
Now, my another, let us say that, we have something like, for the simplicity, what I am doing is, instead of, I want to print the name of the students starting with R. Can anyone help me with the logic? I want to print the name of the student. Okay, I should place a condition in the if keyword in such a way that only the names whose names are starting with R will be printed. Don't think much, because what I will do first, I will get the name. Or there is a method in string manipulation, starts with. You get the name. For example, Balaji. You get the name Balaji. The name Balaji starts with B. That condition is going to satisfy. Our condition is the name starts with R. Now you see the names whose names are starting with R. Raju, Ramesh. Are you getting? Hello?
Yes, sir.
Now I want to see the names whose names are not starting with R. Just I will place it with R. Not operator here in the beginning. Completely the complementary results. Right? So see the combinations here with the in each and every object, you have again internally you have the data types, right? You have the string type, you have the numeric type, and again you have string type. But see how in how many ways you are able to extract the data. So which it is this array list is making it very simple, right? It's making us to work with the object very easily, right? Do you agree that?
Yes, sir.
For now, we are dealing with only only 3 attributes in the student class. In future, we may be dealing with 10 attributes. You want to filter the data according to a condition or according to some kind of pattern. So this is how you do the filtering. Okay. Now see, let us say that I made a mistake. What mistake? There is no such thing like CS department. Okay, it's CSE department. I want to do the manipulation. It's not CS, it's CSE. Okay, wherever the CS is there, it should be replaced with CSE. So I can do that. Same for loop. Okay. X dot get branch dot equals, okay, what? CS, right? Yes. If this condition is getting satisfied, what I do? X dot get branch, okay, CSE. Okay, now you don't see anything in the console. If I just see this, okay, just see. Okay, if I just try to print this reference variable once again, don't you see that CS has become CSE now? Hello?
Yes, sir.
Yes, sir.
Manipulation, no? If any kind of manipulation you can do. Manipulating data, getting data. You can do get operation, you can do set operation, you can do update operation, you can also do delete operation also if you want. So this is what operation? Update or delete operation? This update operation. Or no? Hello?
Yes, sir.
This is how you can do the manipulations by using ArrayList. Now you might be getting a question. See, this ArrayList is under which iterator? Under which interface? Can anyone tell me? This is a subclass of which interface? ArrayList. Hello.
List.
List interface. No, you can directly use it as a parent. What is an advantage of using this directly as a parent? So because of this, will the operation will there be any change in the operation? So now I have an option to create what? Let us say I have an option to create array list of student AL equal to new array list. Now I can say linked list student LL is for linked list, na? List equal to new linked list. Okay. What else we have apart from array list and linked list? Under list, what else we have? Vector, no? Vector v1, okay, equal to new vector. What is the last one?
Stack.
Stack student, okay, S1, not S1. Let me say already S1 is there, no? Yes. Let's keep V for vector. Let us keep S for stack. But the new stack student. So can I say that this AL is of what type? ArrayList type. LL is of what type? Linked list type. P is of what type? Vector type. And S is of what type? Stack type. Yes or no? Right? Now in the runtime, okay, in the runtime, if I don't like, okay, if there will be a kind of some tools in our real-time project. There will be some kind of some tools. You're dealing with only 5 objects here. Right? Sometimes if you want to increase the performance, on the go, and if you want to take decisions suddenly. For example, if you want to do the search operations or the retrieve operations, get operations, or update operation, can you tell me which is better for the frequent retrieval using indexes? Which data structure is better?
ArrayList.
ArrayList is better, no? Okay, if my requirement is okay in the runtime, I want to pick the data quickly. For example, there will be a kind of, let me remove this. Let me remove this everything. There will be a kind of code here, system.out.println. Okay, students dot what is it? Get, we have to pass index, right? Get of 1. If you want to use get of 1, right? In the runtime, I can pass the object of ArrayList here. Okay. Now I can do the frequent retrieval of. In the runtime, I'm not doing anything. The type is list because they are the subclasses, right? They are the child classes of list interface. I'm just changing a type here. If I ask you what is the type of students, you should say type is list. If I ask you what is the object of students, you should say what? ArrayList. Am I changing anything here? This add method is remaining same, no? Am I changing the add method? It is remaining same. I'm changing the variable name. If I run this code, you see what you are going to say. So you see what all the students will be displayed on the console, first thing. Okay. And you are retrieving the data on the index 1. Index 1 is what? Index 1, you have name Mohan, roll number 102, EC. Right? What happens if I go for L1, LL? Okay. The code will work. You are going to see the exact thing in the console. The code is going to give the exact thing in the console. But the get operation for the linked list is a costly operation. Do you agree?
Yes, sir.
So by looking at this, if you know that, okay, somewhere there is an operation called get operation. So we have 4 data structures with us. Okay, this get operation is meaningful when we use ArrayList. You just change this to AL. Now we are just hard coding it. I'm just typing it. Okay. In the runtime, okay, there will be a decisions making. You use a lot of if conditions. Okay. There will be logic for this particular line. What kind of logic? If there is a get operation in the runtime, it will dynamically collect AL. You write logic in such a way that these things are happening dynamically. For the understanding purpose, I am changing this manually. There is a get operation. Can I just use directly? Let us say there is a insert operation. What would be the best option for insert operation?
Linked list.
Linked list is best option, no? Some dot. Okay. What I want to do here is is2 dot students dot add index on the second index. Okay, I want to add a new student. Something like okay, Balaji, not 9. Department is okay, let us say the trainer. Now the student is a reference variable. For which object? Can someone tell me? ArrayList or linked list? This one. Students. Type is list now. Object is of what type? AL. ArrayList, right? Hello.
Yes, sir.
Don't you think that adding an element on a particular index in the array list, don't you think that there will be a lot of shifting take place?
Yes.
Yes,
So
sir.
don't get confused about this. It is similar to, okay, let me remove this. Okay, let me add another student here. Student S6. Okay. we did not add this in the existing list. We are adding it here. Instead of using the reference variable, I used the object directly previously. Both are same. I can use a reference variable, also I can add it directly. Are getting this? So now this AL is a costly operation. When I use AL, this is going to be a costly operation. Let us say that we are not using get method. Let's say that we are using the AL of ArrayList type, but there is a costly operation. I am adding an element in between. I'm adding an object in between. But when you see output, okay, you don't see any changes here. Okay, output will be displayed even if it is for ArrayList. The same output you will see. Okay, Raju, Mohan, and on the third index, Balaji is getting added. After that, you see Suresh. Okay, then you see the remaining persons. You don't see the values will remain the same in the console level. Okay, but it is a costly operation for ArrayList to perform what? To perform the insertion operation on a particular index. Okay, in the runtime, I can dynamically change to LL. Okay, don't you think that now the output is going to be same? Yes or no? Are you seeing any difference in the output? Hello?
No.
Console level, no
No.
difference. Okay, but internally, okay, here the insertion operation is costly, right? For ArrayList. So instead of using AL, there you are just changing the reference variable name LL. This LL is of what type? Linked list type. It will perform the operation. There will be no compromises on the performance, right? And the things in the memory level will become very easy. Likewise, for example, vector. Let us say that you, in the real time, you want to deal with the single-threaded environment. If you have such requirements, you can just change it to V. Output is same. I said no, ArrayList and vector both are same. The different what? The different the synchronization. See, if you take the type as interface, don't you think that you have the control runtime to change the reference variables accordingly to the requirement based upon the data structure? You can take decisions where else you can do the there is always a trade-off. Okay, so if you want to do the frequent retrieval, you go for AL. If you want to insert data or delete data, you go for LL. The other codes remain same. Okay, you don't change anything here. This list is going to be same forever. Are you getting? It will take some time. Okay, if you just take pen and paper and if you practice this thing, okay, you cannot imagine these things just like that. It's going to consume some time. You have to put some efforts. You need to do some practice to understand these things. Now you got to know how to why this enhancer for loop. We are able to filter data according to your requirement. Have you understood that first of all by using ArrayList?
Yes, sir.
Filtering, no? We are
Yes,
able to
sir.
filter according to the name. According to, sometimes there will be parameter like age. Age parameter will also be there. Age attribute. You will filter data of a person whose age is lesser than 18. You filter data for the person whose age is between 18 to 25. If you have so many attributes, you will be getting a lot of options to filter the data. You can do a lot of filtering operations. With practice, it comes. Now this is called abstraction. Sudhir, are you getting at least now slightly what is the abstraction now?
Yes, sir.
You got some little idea
Understood.
about now. You keep the
Yes, sir.
reference as interface or abstract class. Okay. Dynamically, you can change the subclasses, but the common methods will remain same for all these classes. For ArrayList, the common method is add. For linked list, the common method is add. Right. So there is no disturbance for this code. Still you will be getting a lot. Okay, this is the just 40% or 30% I can say. There are a lot of things you will understand when you start working in a company. There is a concept called if you have time, okay, just try to read what is solid principles. This will help you to understand more about the abstraction. For Sudhir, I am saying.
Okay.
Okay, solid principles. Just try to see, just to do some research if you have time on solid principles, or else just leave it. If you want to learn more about this, you can do some research on solid principles. Okay, now let us understand about the iterator. Please rejoin if you just logged out of this meeting. Please rejoin. I will complete the iterator also. That is a very simple topic. It will not take much time. Okay. So to understand iterator, What is an iterator? Anyone know? Have you done any research on iterator? Have you come across iterator? Anyone? Did anyone come across iterator concept? Iterator.
No, sir.
No.
Don't know.
Okay, I will explain this. Source equal to no. Okay. So in see, so what we are discussing, we are under what? We are under the wood. We are not under the wood. Okay, we are discussing this hierarchy list. Under the list, you have these 4 classes, right? So to traverse between the objects, okay. So far we have used what? For loop. We have used what? Enhanced for loop. Okay? And apart from these two, you can also go use what? There is a concept called list iterator. What is a list iterator? It is just a cursor. What is a list iterator? It is just a cursor. What this cursor will do? It will travel 10 and 4. You can either move forward or you can either move backwards. I will tell you. Okay. It is just like using the for loop, an enhanced for loop. Okay, but this iterator will come with some advantages. Let me add some fruits name. Can someone tell me, 4 fruits name?
Apple, banana,
Apple, banana,
mango, grapes.
mango, grapes. Okay. Apple, banana, mango. Please rejoin. Come to .println. So you see what? Apple, banana, mango, grapes, right? So this is not, no iteration is happening, right? It is just printing the values. That's it. I want to convert the array list to iterator. I want to do what? I want to convert array list. What is an array list here? This fruits is an array list, right? Fruits. I want to convert the fruits variable to an iterator or list iterator. How I can do? So there is this iterator. This list iterator is part of what? It is part of the Java util package. It's just like a cursor. Okay, just think like it as a cursor. Okay. See here also it says no. See it is usually performs the cursor positions. If you see cursor positions, it's going to act like a cursor. Now you are dealing with the fruits reference variable, so the type should be fruits here. Give any name. Let me take it as cursor only for the simplicity. Not fruits, guys, sorry, string. Okay, because the data type string. So convert this reference variable to list iterator. Okay. Behind the scenes, these lines of code, okay, will do something behind the scenes. Okay. I don't think I need to give some explanation for this first 4 lines. We know, right? Because of this line, an array will be created. Size, default size is going to be 10. Okay. The first on the 0th index apple, on the first index banana, on the second index mango, and the third index grapes. Thank you for rejoining. Everyone got admitted. Someone admit Sudhira when he's joining. Okay, so now the first 4 lines is going to create these changes. Okay, there are index number will be generated. Default size of an array list is 10. Okay, the indexing will start from 0, 0, 1, 1, 2, 3, and you have indexes like 4, 5, 6, 7, 8, 10. 4, 5, 6, 7, 8. The 10 spaces will be created by default. Okay, these things are done here. Till this, these things are done. So what you are doing the next line, you are in the right hand side, you are converting the fruits reference variable to ListIterator. What does it really mean is, okay, a memory space will be created. The size of this memory space is going to be exact the number of values. If the number of values are 4, the size of the space is going to be 4. Okay, the ListIterator will create the memory space which is equivalent to the size of the array list. Okay, and a cursor will be created. The cursor will be pointing outside. Okay, so this is 0th index, and this is first index, this is second index, and this is third index. A cursor will be created, and what is the name of this cursor? The name that you have given just now. Cursor itself is the name of the cursor. Okay, so this is what happens when you start converting the reference variable of array list to list iterator, right? So it will try to identify how many values are already there in the array list. Okay, in our example, there are 4 values. Okay, so the same size will be taken and indexes will be marked. The cursor will be created. So this line is doing this many things. This particular line is doing these many things. These many things. Right? And this cursor will understand 2 methods. One method is, okay, let us do that. Let me say, we can use while loop. Okay, you can use a cursor reference variable. You can call a method called as next method. Okay, this cursor can understand a method. One of the method is what? As next. When you call as next method on top of this cursor variable, when you call as next method, okay, this cursor will try to see is there any other element. Is there any other element next to this cursor? Is there any other element? There is an element apple, right? Okay, it returns true. Let me repeat. This cursor can understand some methods. Okay, one of the methods are as next method. If you call the as next method on top of the ListIterator reference variable, this cursor will just peek and check whether there is any element added. There is all the element is there already as next. Okay, which means one element is there, which is what happened. It's going to return true. Right? Inside this, okay, inside this, what I can do is I can say system.out.println. There is another method called next method. This next method will move the cursor to the next position. Focus here. This next method will move this cursor to the next position. It extracts the value that is there pointing towards this position, pointing towards this cursor. This cursor is pointing towards a value which is what apple, right? That will be extracted. So the next method will move the cursor, and this cursor will extract the value inside this index, which is apple. Okay. So for the simplicity, I can instead of understanding it like this, okay, let me remove this. System.out.println cursor dot as next. If there is any next element, okay, it will return true. Right? Let us check it is valid or not. True is written. If you want to move the cursor, system.out.println the cursor dot next. Okay. the cursor will be moved to the, from here it will be moved to the first, I mean 0th index, and it will extract the value that is already there, which is apple. Now you will see apple in the console. You will see what? You will see apple in the console. When you repeat this process for 3 consecutive times, you see what? True apple, true banana, true mango, true grapes. Right? I'm printing as next for the last time. It will return false. So every time you call as next method, it is speaking to check is there any other element. Okay. If there is any element, it returns true. Right? As next method will check for any other element and it will return true. And there is a method called next method. Next method will move the cursor to the next index. Next index. And it will extract the value. Again, as next method is going to find is there any value. Yes, there is banana. It returns true. Next method will move the cursor and extract that value. As next method will find is there any other element. As mango is there. Returns true. Next method will move the cursor and extract that value. And as next method will try to find is there any other element. As grapes are there. Returns true. Next method will move the cursor. Now as next method will check is there any other element. No, there is no element. The space is completely void. It returns false. That's why the last statement you see what? You see false in the console. Okay, so this is a kind of the repetitive process, right? So instead of doing like this, I'm just taking what? I'm just taking a while loop and I am converting everything in the single while loop. I'm taking the cursor. Okay, for all the truths, okay, I'm moving the cursor to the index, next index, and extracting the value by using what? By using the next method. Apple, banana, mango, grapes. Likewise, this ListIterator is a bidirectional nature. Okay, there was something like as previous. There's a method called as previous. You will find the previous element. Now the cursor has moved from year to year to year. Okay? The moment you start doing the previous method, it will move from year to year. So if you want to move forward, you can go for as next. If you want to move backward, you can go for previous. Forward, next, backward, previous. So this cursor is a bidirectional in nature. Right? It is not similar to the for loop or enhanced for loop. This is something different. Something different. The complete benefits will be understood in some time. Now if I just execute these two, okay, let me add one line in the system.out.println. You see apple, banana, mango, grapes, and the same things are getting printed in the reverse direction. So this is the next operation. Next method is moving the cursor to the next index and extracting the value. Previous method is moving the cursor to the previous index and extracting the value. Since you are able to move the cursor forward as well as backward, this ListIterator is what? It is bidirectional in nature. Hello? The interview question. Okay, you don't use this in the real-time application. What is a ListIterator? I have given you some theory here. Where is it? So it is an interface that extends iterator. It is only available for list implementations, ArrayList, linked list, vector stack. What is the key features? It will traverse from forward to backward direction. And if you want, you can modify elements by using set operation, add operation, and remove operation. For example, when I say, so let us say that I have I don't have the complete list of fruits. I say, let us say that I have some other vegetable here. Carrot. I want to keep only fruits, not the vegetables. So ideally, what I can do, I can just appoint a cursor. Which is what the ListIterator cursor. I can start moving, right? Inside this, I can place something like if cursor dot next dot equals, okay, caret. Caret is a vegetable. I do not want the vegetable to be part of my root list. Okay, what I do? This is the case. I just what? I just remove that element. Okay. Cursor dot remove. After removing this, if I just print the fruits, before removing, let me print the fruits. Let me run this. Apple, banana, carrot, grapes. Now you see apple, banana, grapes. You can do the same thing with enhanced for loop as well. Okay, but you know, ListIterator is kind of bidirectional in nature. Some advantages are here and some advantages are there. You cannot run the enhanced for loop in the reverse direction. It is only the forward direction. Yes or no? Hello.
Yes, sir.
But here you have an option to run this cursor in the reverse direction also. That's why it is bidirectional nature. You can use remove operation, or for example, you do not like to remove, instead of carrot, you want to replace this carrot with any other fruit. Okay, so there is something like set cursor dot. The moment you catch carrot, okay, you replace that carrot with some other string. Okay, what else we can add here? Any fruit name, guys? I'm not able to recollect. Mango is there, huh? Mango, okay. Mango. Remove carrot and add mango. I want my list to be completely fruits. Run this code. You see apple, banana, carrot, grapes. Now apple, banana, mango, grapes. Okay, set method is doing that. Right? Remove method is removing that. What else we have? We have another method which is what? Get method, add method. If you want to add an additional element, okay, let me say add mango one. Okay. After the moment it finds carrot, next to the carrot, the new element is getting added, mango one. Right? These are the three major operations that we can use for list. The question could be like, what is ListIterator? ListIterator is an interface. It is used to traverse between the collection object forward and the reverse direction, forward and the backward direction. It is also used to modify the elements for set, add, and remove operations. If you want, you can also get index of the correct position. Getting index means there is a method which is called as, okay, let me remove this, system.out.println cursor dot. So there is a method called next index method. This next index method will print each and every index. Cursor dot on the 0th index apple, first index banana, second index carrot, third index grape. This next index is collecting the indexes. Next method is extracting the actual value on that particular index. Okay, so my suggestion is just watch this video before coming to tomorrow's class. Right, tomorrow the set concept will be taken. Okay, watch this video. If you have any doubts, if you want me to revisit this once again with different examples, I will help you to do that.